Okay, carry on now with question 6. Question 6 represents the cost of materials and labor at 2 musical instrument manufacturing plants. In plant X, we make guitars and banjos, and in plant Y, we make guitars and banjos. And each plant has a different cost of materials and labor for each of the 2 instruments. And so we're asked to find the average cost. Well, the average cost is just one plus the other divided by 2, or multiplied by half more properly. And so we add those 2 matrices up and multiply them by 1/2 to find the average cost. So that's what we've done here. Here's all the operations carried out. We add the 2 matrices. 44 plus 46 is 90. So the upper left entries for each matrix become the upper left entry for the sum matrix. And then we add 35 and 39, which gives us 74. 81 plus 85 gives us 166. 102 plus 108 gives us 210. Then we multiply by 1/2. 90 times 1/2, or 90 divided by 2, same thing, is 45. 74 times 1/2 is 37. 166 times 1/2 is 83, and 210 times 1/2 is 105. So this is the matrix that represents the average costs between those 2 plants for materials and labor in manufacturing these guitars and banjos. Now the next part of the question says, well, hey, if we had an increase in labor and materials cost in the first plant, what's the new average cost of production? We have an increase of 20%. What's the new average cost of production? Well, it says we're increasing the cost only at plant X, and that's the first matrix. That's represented by the first matrix. So we would need to multiply, since it's an increase of 20%, and the decimal equivalent of 20% is 0.2. We would multiply that matrix times 1.2 and add that to the second matrix. And that's what you see shown here. 1.2 times 42 is 52.8. 1.2 times 35 is 42. 1.2 times 81 is 97.2, and 1.2 times 102 is 122.4. And so those are the values that we then add to this second matrix, and that gives us these results: 98.8, 81, 182.2, and 230.4, and 1/2 of each of those is 49.4. 1/2 of 98.8 is 49.4. 1/2 of 81 is 40.5. 1/2 of 182.2 is 91.1, and 1/2 of 230.4 is 115.2. So that's that matrix summarizes the new average cost, with the first plant having experienced a 20% increase in both labor and materials. All right, we'll carry on here with question 7. In question 7, we're told that labor costs for a farmer are $50 per acre for corn and $40 per acre for soybeans. And if the most in total labor cost the farmer can spend is $6,200, we want to know what the maximum number of acres of corn he can plant would be if he wants to plant 20 acres of soybeans. So this is an inequality with his total labor costs being no more than $6,200. No more than is translates as less than or equal to in an inequality. And so we let, to create that inequality, we let x equal the number of acres of corn and y equal the number of acres of soybeans, which is why you see $50 multiplied by x, the number of acres of corn, added to $40 times y, the number of acres of soybeans. And together those have to be less than or equal to 6,200. Excuse me. Well, we are told that he's going to plant 20 acres of soybeans, so we substitute 20 in for y, and we have turned this into an equation because we want to know exactly how many he can plant, how many acres of corn he can plant, and that's the very maximum amount that he can plant, and that is the or equal to part in the inequality, which is why we turn it into an equation. 40 times 20 is 800. We subtract 800 from both sides, and we have 50x is equal to 5,400. And we divide both sides by 50 to determine that that he can plant exactly 108 acres of corn. Now, in question 8, we're given an inequality in exercise 43 of section 5.1 on page 262, and we're supposed to graph the feasible region or the solution region for this system of inequalities. Now, I didn't include the x is greater than or equal to 0 and the y is greater than or equal to 0 because those are just everything to the right of the y-axis and everything above the x-axis. The item of interest is this inequality: 15x minus 50y is less than 1500. Well, we need to realize that that if we solve for y to get the inequality that we would then graph as a line and a shaded region, because we have a negative here, when we solve for y, we will then divide both sides by a negative or multiply both sides by a negative and that means we would have to reverse the inequality sign. And so this is the inequality that we would come up with. So I didn't include the y-intercept of negative 30 here in this graph. So we want to graph the line by using the x-intercept, and so to determine the x-intercept, I've put a 0 in for y here, and have solved for x. 50 times 0 is 0, so that leaves 15x is equal to 1500. Divide both sides by 15, and you get x is equal to 100. And so we'd plot that point here, and we would need a second point. We would need a second point to graph the line, and so I've chosen an x value of 150 here to substitute in for x here, and when I solve for y, that gives me a y value of 12. So at 150, this is about 12 here. Looks closer to 15, but it's really closer to 12. And so you would plot that point there, draw the straight line, and you would make it a dashed line because this is a strict inequality. You would then shade everything above that line because of the negative y, that turns the inequality symbol in the other direction. Now you may wonder why we didn't find the x-intercept using this inequality, but when when we're finding the intercept, when we turn this into an equation and find the intercepts, it does not, this direction of this inequality doesn't affect that.